All right. So today we are talking about solving radical equations. We're going to do inequalities for a different video, but mainly we're going to talk about how to solve radical equations. We're live during period 3. So again, if you have a question, you're more than welcome to ask. It'll be on the video. If not, you can wait until the end. I know that a lot of people sometimes like these step-by-step processes. So if you isolate the radical expression on one side, uh, just to one side, and then take the square or cube, you're good. If more than one radical expression, then you can isolate one. Raise each side of the equation to the power of the root to undo the operation. If a radical still remains, you got to repeat it again. I'll show you what that looks like today. And then solve for a variable using any method. Check for extraneous solutions to the original problem by substituting the values of x in. Uh, when you get really crazy complicated numbers, like you're going to see with example 1, not super crazy, but it's going to be a little more than just factoring. It's going to be a little difficult to just check it. Usually it's the numbers that are like the whole numbers or the fractions. Those are the ones that you might want to check, and it's usually with the inequalities that we do that a lot of the times. So in order to solve a radical, the very first thing that we want to do is make sure that we get the radical by itself on one side. So if you notice, we've got the square root of 4x plus 2 and then the minus 3x. We're going to move that over. So we'll end up with the square root of 4x plus 2 equals 3x plus 1. What this sets us up for is we can square both sides. That way we eliminate the radical. That's one of the first things that we want to try and do with these problems, because working with a radical can be very tricky. So by eliminating it as one of our first few steps, we get a little bit of the trickiness out of the way. So since it's a square root, we'll square both sides. We'll end up with 4x plus 2. And then over here, this is like saying that I have 3x plus 1 times 3x plus 1. So I'm going to now make that 9x squared plus 6x plus 1. And that's using that double distribution or FOIL method, however you want to say it. Once you have it in this step, now you want to move everything over and set it equal to 0. So I'll subtract my 4x, and I will subtract my 2. And this is the step where, like we've done in many previous cases in the past, you're either going to want to, see if you can factor. If you can't look at it and be like, oh, I can factor this right away, then use quadratic formula. In this situation, I can't think of anything that's going to multiply to give me 9 and add in negative 1 and then add somehow to give me 2. I'm just going to go straight into using quadratic formula to solve. So x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 9 times negative 1 all over 2 times 9. So x is equal to negative 2 plus or minus the square root of 4 plus 36, so 40, over 18. Uh, 40 breaks down. So 40 is 4 times 10, or 2 root 10. So x is equal to negative 2 plus or minus 2 root 10 over 18. X is equal to negative 1 plus root 10 over 9. Now, in this type of situation, because it's a radical, and if you plug things back in, if I were to take -1 minus the square root of 10 over 9 and plug it back in times 4, I would get a negative number. And then plus 2, I might end up getting something that doesn't quite work out. So in this case, our answer is just going to be the positive. You can plug it into your equation. I'm saving you guys a little bit of the legwork, but you can try and plug it into the equation to see if it will. It won't make 0 per se, but like 4 times, so it'd be like -4 plus 4 root 10 over 9 plus 2. If that comes out negative underneath, I don't know. Does anyone have a calculator? Do you guys want to try it? I don't have a calculator as a thing up here. I'm just remembering from previous attempts. So hold on a second here. 4 times parenthesis -1 minus the square root of 10 divided by 9 plus 2. You know what? It's not going to end up working where it's going to create the same number on each side. So it's not going to work. The positive one, I believe, if I remember correctly from the notes, it will. Will you guys have a calculator or not? I will tell you this. If you do have a calculator, you can see a problem like this. If you don't have a calculator, which I have not yet checked the exam, so I can't tell you one or the other, you will not have something that is super, super crazy numbers. Okay, it'll be nice and neat for you. Don't worry. That's something to talk a little bit about off video. Example number 2, solving radical equations. Square root of x minus 1 is equal to the square root of x plus 1 minus 1. We've got 2 radicals that we have to solve. I want to show you the steps on how to solve for this. Whenever it comes to the square root of x minus 1 and then the square root of x plus 1, you're actually going to have to use the square twice. So first off, because you have at least one radical, that is fine. We'll square both sides. So x minus 1, and then square root of x plus 1 minus 1 times the square root of x plus 1 minus 1. All right, I'm going to use FOIL. So whenever I take the square root of 2 things that are the same, the square root cancels out. So I have x minus 1 on the one side, but I have x plus 1. And then my outside 2, so -1 times the square root of x plus 1. And then my inside, which is -1 times the square root of x plus 1. And then -1 times -1 becomes +1. I now want to combine my terms. So x minus 1 is equal to x plus 2. And then my 2 terms are the same inside of my radical, so I can combine the outside -1s, and I'll get -2 root x plus 2, or x plus 1. Sorry. So now I went from 2 radicals to 1 radical to simplify. So what I'm going to do is, now that I have 1 radical, I'm going to do exactly what I did in example number 1. I'm going to move things over to the opposite side, and then I'll square again. So if I subtract x, that'll leave me with nothing. I'll subtract 2. I'll end up with negative 3 is equal to negative 2 root x plus 1. I'm going to divide by negative 2. 3 halves is equal to square root x plus 1. I'm going to square both. I'll end up with 9/4 is equal to x plus 1. And when I subtract 1, that's the same as subtracting 4 over 4. So I'll end up with x is equal to 5/4. 5/4 is a little nicer number to work with if you're checking your answer. It does end up working out. If you plug it into the original, 5/4 minus 1 is 1/4, and the square root of 1/4 is 1/2. 5/4 plus 1 is 9/4, which the square root of 9/4 is 3/2, minus 1, which is also 1/2. So it does end up being a little bit nicer than the first example. You check. Questions at all? All right.